So we are sending a GET request, this first HTTP request here, whenever this button is clicked. Now, I mentioned that we're dealing with promises here. Fetch returns a promise, and that's why we have these then calls. And just in case it shouldn't be clear, promises are nothing React specific. It's a JavaScript language feature. Now, you might be aware that when you're dealing with promises, you can build these then chains here, so then call after then call, but you can also use an alternative syntax, async await. You can add the async keyword in front of a function and then await an operation which is returning a promise. And it's just a transformation in your code, which behind the scenes basically does the same as if you do use these then blocks. It's just a bit easier to read. Because now you can say const response equals await fetch, and you can remove this then block. And you can then say const data equals response.json and add await in front of that. And then get rid of that and of that, and simplify the code to look like this. Now it's still asynchronous code, as you can tell by the async keyword. It looks synchronous, it looks like we execute step after step, but behind the scenes you can imagine that it's still transformed to this syntax you saw a second ago with these then calls. I just use async await here because it's a bit easier to read, I would argue. So that's something we can also do if we're working with promises here. Again, this is not React specific. This is also a default JavaScript feature. So now let's continue working on this application. We are fetching the movies whenever we click this button, and that's great. Now, we're not really showing any loading state. If I reload this app and I click fetch movies, it takes a second or so for the movies to show up. In reality, you typically want to show some loading spinner or at least some loading text in the meanwhile to signal to your user that data is on its way and you're doing some work. And of course, we want to do this here as well. Now, how could we do that in React world? In the end, it's again just about managing state. We get the movies state, and we can of course tell whether we have movies or not. Now, to tell whether we're waiting or not, we can introduce a second piece of state. We could name it isLoading and setIsLoading. And then add use state and initially set this to false. Initially, we're not loading data. When this component is loaded, when the app component is rendered to the screen, we're not loading data. But when we call fetchMoviesHandler, when this function starts to execute, we of course want to call setIsLoading here and set this to true. With that, we change the state when we start to load. Now, once we're done, so basically after this await block, or after we set movies, but that doesn't really make a difference because these are synchronous tasks. But once we're done, we want to call setIsLoading again and set it to false again because we're not loading anymore. We got some data. And now we can use the isLoading state to render a loading spinner or some loading text. So here we could say that we only want to render the movies list if we are not loading. So of course we can do this as we learned it, wrap this in curly braces, check is loading, and if we're not loading, then we want to render this, which we can do with this shortcut here. So if we're not loading, then we render this. Alternatively, if we are loading, so there's no exclamation mark here, I will render a paragraph where I say loading. So if we save this and we click this button, you see loading here. Only briefly because the data arrives super fast, but you see loading here for the fraction of a second until the data is there. And also if we refetch. And that is how we can show a loading spinner, loading text, whatever you want to do whilst you're loading. Now, of course, loading and not loading are not the only states you might have. We might also want to show a different content if we're not loading, but we got no movies yet. So if movies is an empty array and there is nothing to display. Of course, we could also handle this. We could say that we only want to render the movies list if we're not loading and movies length is greater than 0. So only if we're not loading and we got movies, only then we display the movies list. Here, we want to show the loading text whenever we are loading though. No matter if we already have loaded movies or not. We started a new loading process and therefore, of course, we want to show the loading text. Now maybe we want to show some fallback content if we're not loading and we got no movies though. So here we could say if we're not loading, so we want to display some content, but the movies length is equal to 0, so we got no movies, then we show a paragraph where we say found no movies or anything like that. This of course is just a simple fallback example. Now you see when we reload this application and we therefore have no movies initially, we see found no movies. If I click fetch movies, this will change to loading and then to the movies. And that's of course a crucial part of building user interfaces. You want to let your users know which state your application currently has. And there is a difference between we got no movies, we are loading, and we have movies, of course. Now, when sending HTTP requests, things can also go wrong, of course. You can encounter errors, both technical errors, because, for example, you have no network connection, or you do have a network connection and the request is sent, but you get back an error response code, something like 404 or 500 or 401 codes. And in case this doesn't tell you much, attached you find this Wikipedia article on the response codes which you commonly get. And for example, you will get a 200 or a 201 code, or any 200-ish code, if you had a successful response. So you sent a request and the server was able to produce a successful response. But when sending requests, you also sometimes get 400 or 500 responses. For example, if you're sending a request to a resource which you may not access because you're not authorized, something we'll talk about later in the course when we talk about authentication. Then the request might be sent successfully, there is no technical problem, but the server replies with a 401 or a 403 response, making it clear that it got your request, but it doesn't want to give you the response you wanted. So you then get a successful response technically, but it has an error character because of this error status code, which is attached to it. And you could also be getting a 500-ish response if there was some server error. This is how the web works. Now I can simulate this here if I try to send a request to swappy.dev/api/film instead of films. This is an invalid URL. It's a REST endpoint which is not supported by this REST API. And hence if we save this and we send a request, we don't get back data. It's stuck in the loading state, which of course is a bad user experience. It would be better to show the user some error so that the user of this application knows that things went wrong. Now if we open the developer tools, we see an error here. We got back a 404 response. That's what I meant. Technically, it was a successful request. It left our machine, was sent to a server, and we got back a response. But the response has a 404 status code, indicating that something is wrong with the response. In this case, that we requested a resource the server was not prepared for. Now, as I said, we want to handle such errors. And therefore, we might want to introduce a third state here. An error state with error and set error. Now, initially that might be null, because initially we have no error. And whenever fetch movies handler is fired, we also might want to reset this error to null. Like this, to make sure that we clear any previous errors we might have gotten. But we want to set it to something else than null if we do get an error here. Now, if we're not using async await, if we work with then and so on, then we would add catch to catch any errors. Now, when working with async await, we instead use try catch. So we try some code and we catch any potential errors. So here I want to grab all of that and move that into the try block, and then catch any potential errors that might be caused by the code in the try block. So now whenever some error is thrown here, we will catch it. Now one problem we'll face here is that the fetch API doesn't treat error status codes as real errors. It will not throw a technical error if we get back an error status code. So the problem we have here would not result in an error. We would only get an error in a second step if we then try to operate on data which we haven't gotten. But that's not how we want to handle this. Instead, it would be better if we would throw a real error if we got back a response with the unsuccessful status code. And again, by default, the fetch API here doesn't do that. Axios, on the other hand, this package I mentioned earlier, this third-party library, which you could use for sending requests, would generate and throw a real error for error status codes. Now, since we're not using Axios here, but the fetch API, we have to do this on our own. And it is easy to do that. I mentioned that the response object which we get back has this OK field, which basically signals whether the response was successful or not. So we can check if response is not OK, like this, and then generate and throw our own error in that case. So here we can then throw a new error with some error message of our choice. We could read an error message from the error response we got back from the server, or use our own error message, which is what I will do, and I'll just say something went wrong here. Now we throw this error if we have an unsuccessful response. And since we throw an error here, we of course won't continue with the next step in line. Instead, we'll make it into this catch block. And here, we can now call setError, and set this equal to error.message. So now error is a string. It's this string here, in this case, to be precise. And with that, we're managing this error state. Now we also want to, of course, output it down there. We want to output some content based on whether we do have an error or not. So we can, again, render something conditionally, and we can check if we're not loading, because of course, if we are loading, we want to wait what the result of that is. But if we're not loading, and we do have an error, so if that is not null or undefined, but if we do have an error, then I want to display this error. So then I'll render a paragraph with this error text inside of it, like this. And I also, of course, want to make sure that we always stop loading. Even if we have an error, we're not loading anymore. So we also want to set is loading to false here, or we simply move it after this try catch block, so that we always set is loading to false, no matter if we have a successful or an error response, because either way, we're done loading. And with that, if we save this, if I click fetch movies, we're loading, and then I get some output here. Found no movies, and then my error message here. Now that's not the error message I'm setting here, because actually here I'm calling JSON on the response, and this already fails because we're not getting back JSON data for this request for this invalid API endpoint. So actually I should check for the response being okay before I even try to parse the response body. Now the exact way of handling the error response depends on the API you're talking to. Some APIs also send back JSON data if the request was not successful. Other APIs like this one send back non-JSON data. So therefore here we need to handle this before we try to parse that. With that though, if I now click fetch movies, we see something went wrong. I also see found no movies, which of course is not what I want. I want to make sure that we only show this fallback text if we're not loading, we got no movies, and we got no error. So here I'll check that we have no error in addition to the other checks. And with that, if we now try this again, then we have this state. And if I fix this error by adding the S again here, and we now save this, we of course can successfully fetch movies again. And this is how we can handle all the different states we might have when sending HTTP requests. And this is important because no matter to which backend app you're talking, you will always have these different states. You will always be waiting for the response. You might always be getting errors. You might always be getting back your data, hopefully, and your data might always be empty. At least in most cases, it might be empty. And therefore, it's important that you know how to handle these different scenarios. Now, of course, instead of writing all these inline checks here, we could also write this more elegantly. We could add a new variable, content, which by default, let's say, is found no movies. And then we set it to something else depending on which state we have. So we can check if we're loading, for example, in which case we set content equal to loading or whatever you want to display when you're loading. Now we can also check before we check for loading, because this should override everything. So I check for it last. Before checking that, we can check if we have an error, if that is truthy. In that case, we can set content equal to error. And of course, we might also have our data. I mean, hopefully that is what we have in the end. So we can check for that first. We can check if movies.length is greater than 0, in which case content should be equal to this movie's list here. So let's grab that and set content equal to that here. And now we can replace all that inlined output down there with just rendering content, this content variable. And the value stored in the content variable will now differ based on the state we have. It's either found no movies, or loading, or our movies, or again, if I temporarily remove that S here, like this, then it can also be that error message. So that's how this works, and that's how we can handle these different states.